Hello, my name is Sarah Kosia. I'm a sophomore physics major at Drexel University, and I'm going to explain to you the physics of how a figure skater jumps an axel. An axel is a jump where the figure skater takes off forwards, rotates 1.5 times in the air, and lands going backwards. When a skater jumps an axel, they have three fundamental principles at work: the motion around their broad takeoff curve, the force they exert on the ice to go up, and the torque in the shoulders that accounts for rotation. The circular motion around the takeoff curve is the only factor in the forward momentum of the jump. The pushdown force is the force the skater's leg exerts through the toe onto the ice. It sends the skater into the air, where they are in free space and no longer have friction from the blades on the ice. The twist in the shoulders is due to the force my muscle exerts to keep them parallel to the line of travel and perpendicular to my hips. As you can see by the yellow strips marking my shoulders and hips, along with the vertical line down the center of my body, they are working against each other because while on the ground, the forces are in equilibrium and I remain still. But as soon as I take away friction, which is the force balancing the force creating the torque in my shoulders, my body rotates. The initial angular acceleration is quick, and the majority of the jump has a constant rotational velocity due to the initial snap of attempting to equilibrate. This attempt to equilibrate carries me through the rotation at 9.4 radians per second, which means I go around a circle at 2.3 times a second. Assuming that I am basically a cylinder, and negating the motion of my arms and the checkout force, the force that causes the torque in my shoulder is roughly 600 newtons. And I just think this is so cool because not only am I exerting 600 newtons of force, I mean, that's not a number to sneeze at. I'm also learning exactly how my axle works. I'm validating every piece of advice a coach has given me over the years, which, believe me, is a lot. I can make my own corrections using what I found. I can make the correction if I didn't make the rotation, maybe I have to put more force in my shoulders. Or even when I'm landing, maybe understanding that I need to go back into equilibrium in order to check out properly so I don't fall. And I can look at this and I can write it down in variables and symbols and numbers that other humans understand. It's just such a surreal thing to take two things I really, really love and bring them together and create this beautiful understanding of sport and the world in a quantifiable, mathematical, physical sense. It's just such a neat idea and it's such a neat experience.